Let's go ahead and start. Today, we will focus how to create agents in LangChain. If you see, till yesterday, we were creating the applications. So if you see here, this is one of the application we created. Like this, we created many applications, right? Here, we are trying to import the model, import the necessary libraries, and then we are initializing the models. Then we are trying to invoke the model by passing our prompt, our message. Then model is responding. That response we are displaying. This is what, like this, we have seen many examples around it. Like this, we have seen many examples around this. If you observe here carefully, what are we trying to do? We are sending the prompt to model, and the model is responding with the answer that we are displaying. This is what we have done till now. Okay, if you go to our documentation, so till now, this is what mainly we are doing. We are trying to send our prompt to the models. Model is responding back, and that response we displayed. Is this a real agent? Is this an agent? It's just like you are asking the question. You are asking the question. If you see here, this particular piece of code, if you see this particular piece of code, you asking question, and model means LLM is responding. Model is responding. This is what it is. Is this the agent? Agent is more than this. The question is, now the question is, okay, so is that the agent? So agent is more than that. Agent is more than this. What does it mean? Okay, what does it mean? Let's learn. What does it mean? Let's learn. Before we go further, we have AI. We have some terminologies, right? AI and agent, AI agent or agent AI. Some people says AI agent, some people says agent AI, and there is a agentic AI. Agentic AI. Like this, we have some terminologies. What this terminology is about? What is AI? AI is nothing but artificial intelligence. That means intelligence capability. AI is nothing but intelligence capability or artificial intelligence. Intelligence capability. Intelligence capability. This complete definition and all we already studied enough. So if you are not followed the previous session, you can go back and refer the session 1. So AI means artificial intelligence. So that means giving the intelligence capabilities. Making a machine with the intelligence capability is nothing but AI. Then what is agent? Agent means a entity that acts. Agent means a entity that acts. A entity that acts. That's called AI. Sorry, agent. A entity that acts. Then what is AI agent or agent AI? Okay, agent, that means a entity that acts. Agent powered by AI. So it's a simple definition if you see here. Okay, so if you understand carefully, what is AI? Making a machine with the intelligent capability. Fine. What is an entity? Sorry, what is an agent? Anything, a entity, anything or a entity that acts. That means it is going to perform something, it is going to do something. We will learn what it is going to do, all those things. So agent means something, it acts, a entity which acts. Okay, fine. So I am saying agent will act, right? Then what is AI agent? AI agent means it's an agent but having the intelligence capabilities. That means it acts with the intelligence. A entity that acts with the intelligence. In a simple word, you can also say like this: a entity that acts with intelligence capabilities. Intelligence capabilities is called AI agent. What does that mean? That acts with intelligence capability. We will practice so many examples coming. We'll practice one by one. Then agentic AI. Agentic AI, see, AI agent means it's like a specialized agent. Agentic AI means it's a journey. It do everything. That means it transforms AI from. We already discussed all these things here. We already discussed all these things. If you want more details, please refer our initial sessions. Agentic AI means it transforms AI from answering the questions to executing the goals. Executing goals. So that is called agentic AI. Anyway, agentic AI we will do more in coming. For now, important is agent. Agent means that acts. AI agent. AI agent means a entity that acts with the intelligence capabilities. That is what we need to start understand. That is what we need to start developing. So therefore, going forward, we are going to create AI agents. What does it mean? A entity that acts with intelligence capabilities. A entity that acts with intelligence capabilities. What does that mean? Okay, a entity that acts with the intelligent capabilities. What does that mean? So if you see the picture, I'll just show the picture here. Let's say you developed one AI agent. AI agent means what? Agent means a entity. You developed a entity with the intelligence capabilities. What it will do? It is also a software here. Please remember this. AI agent is also a software. Okay. What is AI agent? Now let's understand AI agent, right? So AI agent, okay, is a software or a system or a program or software program system. Okay, AI agent is a system or software program. Okay, software program that goes beyond simply answering the questions. Simply answering questions. That's what I said. It's not only just answering the question. It will do more. What is that more? We will calculate it now. So in a simple word, what is AI agent? Okay, entity that acts with the intelligent capabilities. What is the entity? A software, a program. A software, a program. A software, a program. Assume that you have written a software. Assume that you have written a system. That is called, when that is called AI agent, assume that this is what you have written, AI agent. That AI agent is not just answering the question, it is more than that. What is more than that? So it will have a memory, remembering capacity. It will have a reactive capabilities. It will have a API calls. It can do web search, internet search. Okay, it can delegate the task, then it interact with the databases. Like this, it will perform n number of activities, not just answering the question. If you see the program application, whatever we created till now, we passed the prompt and it is answering it is answering. That's like a question answering till now. But AI agent is more than that. What is that meaning of more than that? So if you come back and see one more time, as I said, AI agent, it's a software, it is a system. It is a software, it is a system. Okay, then what it will do? It do beyond, it will do, okay, beyond answering questions. That means it will do more. What does that mean? It will do more. It will do the dynamic decisions. We will practice all these examples. It will do the dynamic decisions. So that means if you are writing a AI agent, it is a software, it is a system, it is like an application like this. What is a AI agent? It's like a software, it's like a program. Then what are the specialities of this program? It is not just answering the question. It's beyond that. Okay. That's why I said it do beyond answering the question. What does it mean beyond answering the question? It will take the dynamic decisions. It will take the dynamic decision and based on it, based on it, it will based on the based on it next. It will act next. Based, it will do the dynamic decision. Based on the dynamic decision, it will act next. What does it mean? We need to practice with the examples. For now, if anyone asks, can you explain what is AI agent? You need to tell that it is a software, it is an application, or it is a program that do more than just answering the question. What does it mean more than answering the question? It will do the dynamic decisions. Based on the dynamic decision, it will act next. It will learn. It will act next. It will learn what to do next. It will learn next. So what to do next, it will learn. And it will remember previous interactions. It will remember previous interactions. So let's say I am saying, right now I am saying, let's say my name is Chenna. After some time, if I go ask what is my name, it will tell that Chenna. Like that, it will remember the previous conversations. And it uses the tools. Okay, it uses the tools. Okay, what is the meaning of tools? So please remember this. We will start coding the tools. Tools are nothing but functions in a simple word. Tools are nothing but functions in a simple word. So if you know C language also, in the C language we write the functions, right? So here we call it as tools. This AI agent will use the tools to do more interactions with the databases, with the external databases, external APIs like that. Next, uses the external APIs, okay, databases. Uses the external APIs, databases. Like this, it will do n number of things. Like this, it will do n number of things. So if anyone asks a question, what is AI? Making a system with intelligent capabilities. Agent, a entity. Entity means it can be anything. A program, software that acts. Then AI agent. Agent that powered by AI. That means a entity that acts with intelligent capabilities. Then agentic AI, it transform answering the question to executing the goals. This is what our end product. We will focus on this more in the coming days, exercise more in the coming days, but the introduction part and all we already explained. Okay, now going forward, we are going to create AI agents. That means this part. Okay, now we want to create a AI agent. What is a AI agent? It's not, it is a system, it is a software. It do more than just answering the question. What it will do more than answering the question? It will remember the stuffs. Okay, it will make the decisions. It will find out what to do next. It will use the tools to talk to the to do more actions, to do more activities. It will talk to the external systems, external databases. Okay, it will talk to the internet, get the more information. Like this, it will perform n number of activities. That's why if you see here, not just model, it will do many activities. That's about the AI agent. We'll see, we need to practice all these things, how it can make the decisions, how it can remember, how we can use the tools, how can we use the APIs, external APIs, how to use the web search, okay, weather search. Like that, we'll do so many examples coming. That's it. That's about the AI agent. Now let's see the nodes once. So this is what I'm telling. Okay, you can see, you can also see here. You can also see here. Let's say you developed one AI agent. What is AI agent? It is a software. It is a system. What it will do? So what it will do? It can delegate the task. That means instead of it to do everything, you can also transfer some of the task to some other. Okay, it can delegate the task. It has the memory. Okay, then you can see it can use the API calls. It can use the tools. Tools are nothing but tools are nothing but functions. Right. Now come back here. Okay, come back here. Sorry. Okay. Now you can see it can talk to the internet. It can have its own environment. It has the memory. It can do autonomous actions. Like this, it can do a number of activities. That's about AI agent. Now it's time to create AI agents. We'll create it today. Okay, it will take time, but we'll go one by one. Now it's time to create. It's time to create AI agents. So what is the AI agent? It can have the memory. It can have the external calls. It can have the n number of activities. Now let's see one by one. The first important one is, let's see the basic one. I will say scenario 1 or case 1 or scenario 1. Case 1 or scenario 1. What scenario 1 is? Let's say I have a prompt. Let's understand the requirement. I have a prompt. The prompt is add 10 comma 11 comma 12 and then divide by 5. This is the prompt. So we'll consider different scenarios and understand. We'll consider different scenarios and understand. First, I have a case or scenario where I have the prompt. That means I am inputting add 10 to 10, 11, 12, then divide by 5. I want to see the results. Okay, then display the results. Display the results. This is the requirement. This is the scenario 1. This is the case 1. Then how to do this? How to do this? Let's code it. Okay. Let's go to our regular application. Let's go here. And obviously, the required imports are needed. So therefore, I will copy this program. We'll modify it. Let's go to this new cell. I just pasted. We need the all the environment variables. These are all needed. All the environment variables. That means read the variables from .env, because in the env file we have we have API keys, all those things, right? We want to read those. For that, these two lines we add it. We discussed it already enough. And OS library to get the environments like os.getOf models, all those things. We are going to use it. And this is what we are using before. This is what we are using before. This time we will use the chat OpenAI. Okay, so import from LangChain. Okay, from LangChain underscore OpenAI, specific to OpenAI. Import chart OpenAI. This we studied already. Now we need to initialize the model. How did we do? This is how we have done, right? Let's say RRRS underscore model. You can say model or LLM. You are fine here. But yeah, RRRS underscore model. Then I want to initialize the model. Model is nothing but LLM. How we can use chat OpenAI. So this is specific to OpenAI coding. That means GPT models. This is specific to OpenAI coding. GPT models we already seen. Then specify the model information. Model equal to os.getInfo of getEnv of. Then what do we have in the environment variable? So model. What do we have in the environment variable? Model. Okay, we need to specify the model, and we can specify the temperature. We discussed all the temperature and all before. So let's say temperature I'll put 0. What is the meaning of temperature 0? So don't assume anything. Give exact answer like that. Okay, so temperature. Okay, you can click on this. What's sampling temperature to use? We discussed this number from 0 to 2 like that in the initial classes. Just refer that. Okay, now fine. So if you observe here, what are we trying to do here? We just imported the necessary libraries, then initialized the model. Once you initialize the model, now you need to send a request to the model. Invoke the model, right? Invoke the model. Okay, invoke the model. How do I do that? You can say RRRS model or LLM dot invoke. Then what is the prompt you have? This is the prompt. Add this one like that. So specify it. Okay, specify it. So here there is a bracket, you can remove. That is not required. So therefore, invoke the send a request or send a prompt to the model. That's nothing but invoke. How do I do that? With the model. Model dot invoke of. Then you can pass the prompt. That will give the results, right? That results you can display. Now execute this program and see. Execute this program and see whether we are getting the results or not. Yes, we got the results. We got the results. So if you want to see the clear output, this is the response. In the response, we have the content, right? So you can say response.content. RRR is response.content. Now you can see it. You can also say, you can also use print, right? So print results equal to like this. If you want this also, you can do it. You can do whatever you want. This we already discussed enough. Now you can see. Now you can see RRRS content, right? So what did we ask? Add 10, 20, sorry, 10, 11, 12, then divide by 5. This is what we asked. This is what the prompt. Then this prompt sent to the model. This prompt sent to the model. So it is calculating 10 plus 11. Okay, plus 12, 33. Then 33 divided by 5, 6.6. That is what it is returned, and we got the response. And we displayed the response. And we displayed the response. If you simply do like this also, just say print content. Now you can see. That is what you can see here. There is a new line. When we use the printf, right? Or when we use the print, that new lines are printed. In the response also, we have already new line. So you can see new lines, backslash n, backslash n. Because of that, that print is displaying in the new line. So that's why better to use print so that you can see clearly what are all executed behind. What are all executed behind. That's it. So therefore, in this program, what are we trying to do? We imported the libraries and we are using the chat OpenAI to talk to the OpenAI models, which is nothing but the GPT models. And we initialize the model. Then we are saying model.invoke of, we pass the prompt. This send the request to the model. Now model, that means right now model is what? OpenAI model, that's nothing but the GPT. That's what we configured in the .env file. That's what we configured in the .env file. So that is taking this prompt and first add three numbers, right? So it is adding, we got the 33. Then we have a prompt divide by 5. So 33 by 5, it is giving 6.6. That is returned to us. Whatever returned to us, we displayed here. Whatever returned to us is displayed here. All the, if you see, if I simply put the RRRS response, then model return the response to us. How? As a AI message, right? Let's see. We should have AI message. Okay, now you can see AI message. So if you see AI message also, that is what we have. We see AI message also, that is what we have. From these results, we have taken the content and displayed like this. Okay, this we understood and this is one. Now, if you observe this example, what exactly happening? Let's see the flow now. This is the program. Let's see the flow now. So this is the case one. This is the case 1. Now if you see the case 1, this is the prompt and we got the results equal to how much? 6.6, right? Yeah. We got the results equal to 6.6. Then in this case 1, scenario 1, who is doing all this math? Who is doing all the math? Model is doing. So therefore case 1 is all math done by models in bracket LLMs. So that means addition, division, everything is done by, this is the prompt. Then who is doing that additions, divisions, all those things? My model is doing. Then it is given the response, that response we displayed. So therefore scenario 1 is let all the work done by model. That's the scenario 1. Scenario 1 is what? Let all the work done by models, means LLMs. That is the scenario 1. So in this case, it's a math, all math done by the LLM. That's what you can see. That's why if you see the flow, this is the excellent flow you can see here. This is the complete flow of it. Can you please observe? I will just take this into the paint. Okay, I just taken this into the paint. Let me do one thing. I will try to minimize it like this and paste it. Now expand it. Yeah. Okay, I will just a little bit minimize. Okay, then I will expand to the left and put our program here so that you can see what exactly we have written and how the flow is happening. What exactly we have written and how the flow is happening. This is what we have written and this is the output we are getting, right? This is the output we are getting. Now let's see. Let's understand, please. Okay, let's understand. I am explaining the flow in this picture. So this is the Python program. First, we are trying to load the, okay, so load.env, that means environment variables. Once that is done, we created chart to OpenAI. Okay, chart to OpenAI. Then what did we do next? Okay, then what did we do next? Can you please go back to this paint? So there is a invoke method and we initialize the model. Okay, we initialize the model also, chat GPT model. Okay, once that is done, there is a invoke method. This invoke method internally uses lots of logic. This invoke method internally uses lots of logic. Okay, you can see here, please. First, we loaded the environments. Then there is a chat GPT. So we created a client of that. We initialized the model. That means we created a client of that. Then there is a invoke method. Now there is a invoke method. For that invoke method, we pass this prompt. This is the prompt. That invoke method will do lots of things internally. That is what we need to understand now. What it will do, it will, right now we are using LangChain, right? If you see here, all the magic is with the LangChain. So therefore, LangChain layer, that is what our code layer. That is what our code layer. Now we entered into the LangChain layer. That LangChain, okay, when you say invoke, the request get created. Okay, the request get created. What request? HTTP request. What request? HTTP request. So this is how it will be. Slash v1 slash chart slash completion. So if you remember our previous coding, this is how we did. Okay, once that is done, now it is going to the API layer. It is going to the API layer with that information. What information? With the prompt, temperature, parameters, all those things you can see. With the model information, temperature information, prompt information, all these things. And if I simply enter like this prompt, it's a user prompt, right? That's why you can see user here. That internally talks to the models. That internally talks to the models. That means all the information, whatever we entered. we'll go to the model. Right now, which model is configured? If you go to the environment variable, so GPT 4.1 is configured. So that's why GPT layer. Then request is sent to the GPT layer. That means model that process our prompt. Our prompt is what? It is having two steps, right? One is add all these numbers, then divide. So that is what it is. Add all the numbers and divide. So therefore, all the work is done by the models. Then it is giving the response as 6.6. Then it is giving the response as 6.6. That is returned back. That is returned back to the API. Now API is mapped that one to the and return to the LangChain as a AI message. You can see that is a AI message. That means all the information whatever is written is kept in the AI message. Now from the AI message we are taking. So you can see from the AI message we are taking and displaying. We are taking and displaying. This is how the complete flow. This is how the complete flow. So therefore, if anyone asks, can you explain how the execution flow? First, okay, this is how you need to say. First, environment, load environment variables, then create the client. So in this case, chart OpenAI client, then invoke, okay, model or client dot invoke. That will create a HTTP request. That HTTP request will send all our information to the model. Model receives it and process it. Once it is processed and it return back to the API layer, we will do the mapping all the information into the AI messages. That AI message is returned to the front end and Python code. There you take from AI messages and display whatever you want. That's it. That is a complete flow. That's it. That is a complete flow. Now let me show you the notes for this. Okay, if you see in this example, in this scenario, all the work done by the model only. All the work done by the model only. Now let's go back to our notes. As I said, AI application. So we are trying to develop a AI application where LLM do all. That means there is nothing tool, there is nothing decision, there is nothing memory, there is nothing plan. That means we have just using the model. That means we are fully depending on the model to do everything. That's what we have done, and we have got the response. And this is the complete flow I kept here. This is the complete flow I kept here. All right, that's the scenario one. Now let's keep extending. So in case of scenario one, let all the work done by the models, right? Let all the work done by the models. That means so add 10, 20, 30, sorry, 10, 11, 12, then divide by 5, and we got the response. That means we fully depend on the model. So in the scenario one, in case of case one, we fully depends on model's response. We fully depends upon model response. But do you think that model have always correct answers? So the question is, next question is, do you think that what is a model? Model is nothing but what? LLM, right? LLM. In this case, it's a LLM. What is a LLM? It's just a memory. It's a brain. Okay, it's a brain. We already studied. What is the model? In this case, model is nothing but the LLM. LLM is nothing but the brain. What it is? It's a trained data. It's a trained data. Now the question is, okay, now the question is, what is the guarantee that the trained data will give 100% accurate results? What is the guarantee that, okay, LLM means brain, means trained data. What is the guarantee that LLM gives 100% accuracy? There is no guarantee. Okay, there is no guarantee. Okay, there is no guarantee. What is the guarantee that LLM give 100% accuracy? There is no guarantee. Because if you see, right now we are using which model? Okay, right now we are using which model? GPT 4.1, right? GPT 4.1. Let's see when this got trained. It would be having old data also. Let's say I'll just go here. GPT 4.1 when it trained. GPT 4.1 when it trained. You can see it trained May 2024. That means till that it is having the information. After that, let's say June 2024, it is not having. So let's say I'm asking give India latest information. It can give up to May 2024 only. It will assume that 2024 is the last, and whatever it has, it will give. It will not give the latest one. That is the problem. So let's say I'm asking I'm asking the prompt. Let's say prompt is like this. Prompt is explain about India in 2 lines. Explain about, let's say, explain stock news or explain India stock news in 2 lines. So explain India stock news in 2 lines. This is what I asked. Then it will give the answer. We get the response, but the response is whatever is available in the trained data. It may not be accurate. That means from last 2 years data is not there in that particular model. So it will assume something, it will guess something, it will give something, whatever available, the best, which is not which may not be 100% accurate. That is the challenge. That's why we should not depend fully on the models. We should not depend fully on the LLMs. Okay, so contains response uh, from GPT 20, this one, which has the information till May 2024 only. After that, no information. It will give something here. It will give something, but it may not be accurate. It may not be latest. So we need to tell so many things here. That's why depending on models, 100% not suggestible. Okay, this is the best scenario. Then what to do? Okay, depending on models, let's say I'm asking a question here. Tell today's, I'm asking one more prompt. This is a prompt one. Next to prompt two is what? So this is the prompt one. We understood. Okay. Then prompt two. Let's say I'm asking one more question. Explain or give yesterday's gold price. Yesterday's gold price. Will this give yesterday's gold price? Because it's a trained till 2024 May. After that, it is not having a latest information. So therefore, it may not. It may not give correct answer. It may not give answer or incorrect information. These are the challenges. Like this, we have challenges if we completely depends on models, means LLMs. If we depend completely on the LLMs, may not be accurate, may be having old data, it may misguide it, it may miscalculate it. We don't know because it is a big brain. It is a big brain. From the brain, it can do so many things and give something, which is very hard. So then what to do? Then what to do? So the answer is create tools, means functions. Create tools means functions. Write your logic. Create tools means functions. Write your logic. That's it. Create tools. means functions. Write the logic. Write your logic. That's it. So therefore, case one is what? Let models do everything. Okay, if models do everything, I explained the challenges. I just taken prompt one, prompt two. We have some challenge like this, n number of challenges here. Like this, n number of challenges, not this one only. Then what to do? So we need to create the functions, tools, and write your logic. That logic is what? Let's say that logic is what? For second prompt, get yesterday's price. Maybe I can do a web search and get it. Instead of depending on the model, do a web search and get it. Okay, I will give you one more thing. Another prompt. Prompt 3. Prompt 3 is what? Explain ChennaReddy triple RS. Model having, right? Model may not be having. Model might not be having. Might not be having. Okay, then how do we solve all these problems? We can solve by creating tools. Tools are nothing but functions where you can write your logic. So let's say explain ChennaReddyTraining. If I go to the google.com and type it, okay, ChennaReddyTraining, am I getting response? See, you are getting some response. Then what I can do? What I can do? I can tell to the agent. I can tell to the agent, hey, first, if someone asks a ChennaReddyTraining, if someone asks a ChennaReddyTraining, go to these functions. Okay, in this function, I will tell that get from the web. Get from the web means like this, like how I did just now in the Google. Get from the web, take it and display it. Like this, we have the solution. That's why AI agent is not just answering the question. It can beyond that. So it can use the tools, it can use the functions, it can talk to the web search, okay, external APIs, databases, decisions, remembering, like that many things are there and we are trying to introduce one by one. Now case 2 or scenario 2. What is the case 2? Scenario 2. So here let everything done by the models, right? Let everything done by the models. Let everything done by the models. Now let everything means what? This prompt. Now let everything done by the tools. When I say let everything done by let all work means what? All math work. Let me use that word. Let all the math work done by the models. This is the scenario 1. Now scenario 2 is let all the math work done by my tools. So that means I will not depend on models. Scenario 2 is what? Let all the math work done by tools. Tools are nothing but functions. Then what is model will do here? We'll see. What model will do here? We'll see. Okay. So that means all the work means this one. Let all the work done by the let all the work done by the let all the math done by the tools here. Sorry, model here in the scenario 1. So here let's tool will do. Let tool will do. Then finally we'll compare it. Okay, finally we'll compare it. So right now let's go to here and let me run this one more time. I'll just for scenario 1, please understand this. For scenario 1, when I displayed like this, I just have only one message. I just have only one message for scenario 1. You need to start understanding these messages now. Okay, let me take into the paint and put that here. Okay, one second. Okay, so this is what we have for the scenario 1. Okay, good. Now what I will do is that scenario 2 is what? Let all the work done by my functions, my tools. All the work means what? So this addition, division, all those things. Let's see how do we do that. So if you want to do that, then I will put this program, let it be. I will copy this program, go to the next cell, paste it, go to the next cell and paste it. We will use the imports the same, and we will use the model also, initialize the model, means LLM. All these things will keep as is. All these things will keep as is. Now we need to write the tools. I don't want to rely on this. So let's write the tools. We can also write, let's do one thing. This is a common logic, right? This is a common logic. So let it be in one cell. That is a common logic. Let it be in one cell. So that means imports, then OS, then initializing the model. Import OS and initializing the model. Let it be in one cell. Now we'll write the functions. Okay, let's go to the next cell. Just execute this. Make sure that is successful. Yes. Now in the next cell, you can also keep everything in one cell here. No problem. But for clarity purpose, I am just maintaining different cells. Now define the tools. How to do? Okay, define tools. Tools are nothing but functions. Tools are nothing but functions. Then one question is define tools, right? Tools means functions. Who will call those functions? Who will use these functions? Okay, LLM can call. LLM can use. How it will use, we will see. So if you want to write the tools, then you need to import LangChain, LangChain dot tools. There is a tools. Then import, okay, tools. Tools are nothing but functions here. That's it. Tool is nothing but the function. How do I write it? You can annotate as a tool. You can annotate as a tool and write the function. How do you write the function? Definition. Then I want to, what is the prompt? The prompt is nothing but add three numbers, then divide. I'll write two functions, let's say. I am just writing add one, which will take two variables. Let's say A integer, B integer, and returns also integer. And you need to mention. So this is a function, right? What this function will do, you need to describe clearly. Here function name is not matter, tool name is not matter, description is the matter. Tool name, what is the tool name here? Add one. That's why purposefully I am giving add one here. Tool name is not matter, the description is the matter. That's why you need to tell clearly description so that model can understand that, okay, this particular tool add two numbers, this particular tool add three numbers, like that. So therefore this is adding two numbers. This is adding two numbers. How? You can write the logic. How? You can write the logic. That's it. So this is what a tool, this is what the function. This is what the tool, this is what the function. Now I will not ask a model to do it. I will just ask model to decide it and call this. Now here I will write the logic. Let's say B value is coming from database. See the power here. If we are fully depending on model, it will always give 10 plus 11 plus 20. Sorry, 10 plus 11 plus 12. Now let's say I want to say A plus B. Here I want to, this B value I want to get from database. That is also possible. I want to get from some other place. That is also possible. That is the power of writing these tools. Okay. Now let me write one more tool. I'll just copy this for speed purpose. I'll write three tools. You can write whatever you want. So going forward, how to write the tools? You can annotate with the tool. That's and definition, then tool name or function name, then whatever parameters you want. You want to add two numbers, therefore input two numbers and give the proper description and so on. Now I'll write another method called add to. which will add three numbers. Which will add three numbers. So you give the proper description, add three numbers. Okay, then A plus B plus C. Now tool 3, another tool. Let's say I will just give, you can give any names. I am purposefully giving names like this. RRRS division. But there are best practices here. You should not give names like this. Best practices also we need to follow. For now, I am just giving different names to see, to understand which is important. Description is important or this tool name is important. So obviously description is the important to understand what this is doing. Okay, so therefore division. Division is nothing but what? That results we are dividing, right? So that's why dividing two numbers. Dividing two numbers. How you can do? A by B. A by B. Like this you can write the tools. Like this you can write the tools. Then what are all the tools you have written? Store it in list. Store or put or keep. Store or keep all the tools in list. How do I do that? You can just say RRRS tools. It's just a variable. RRRS tools equal to, then keep in the list. So that means you just mention what all we created. Add one, add two, then RRRS div. RRRS div. Like this you can do it. That's it. So add one, add two, RRRS div. These are the tools we have written. Then what you need to do is that, we created a list, right? Now create a lookup dictionary for these tools. Create quick, that means what are all the tools available, right? For that, create lookup, quick lookup dictionary. These are the fixed steps here. Click quick lookup dictionary for these tools. For these tools. How do I do that? See, going forward, it is very fixed. You need to do the necessary imports. Then this is how you can write the tools. Then put all the tools in the list. Then put in the, okay, put in the lookup dictionary. How do I do that? Let's say tools. This is also called as tool mapping. Okay, dictionary list is this kind of bracket. Dictionary means this kind of bracket. Please understand going forward. This is the Python syntaxes. If anyone knows Python, that's fine. If you don't know Python, just say that if you are using this kind of bracket, it's a list. If you are using this kind of bracket, it's a dictionary. Then tool dot name. So what are the names we have? These are the names, right? Add one, add two, like that. Tools for tool in this. That's it. So the tool name is tool. And how do I get that? I am just writing a for loop because we have many. Okay. And get it from this particular list. That's it. That is how you can create the tools. That is how you can keep the tools in the list and map it. That's it. That's it. That's it. Okay. That's how you can create the tools. Nothing more than that. Then the next cell, we'll just go to the next cell. We already created the model, right? You can see this, we created the model. All good. Okay. Then what you need to do is that how model knows you have written the functions, you have written the tools. Let's say right now what I am trying to do, I will say that add 10, 20, 30, divide by 5. This is how I am giving the prompt. Now model is giving the response. In case of case 2, how model knows you have the tools to do this task. How model knows you have the tools to do the task, so that it will hand over the tools, so that it will it will tell that let the tools do it. So therefore, it's time to bind the tools to the model. Okay, so it's time to bind the tools to models. Models are nothing but LLMs. It's time to bind the models. That means we are telling to the model, hey, I have written the tool, you don't do it. I have written the addition, you don't do it. I have written the division, you don't do it. So therefore, bind the tools to models. Bind the tools to models, LLMs. That means we are telling the model, hey, I have the tools. You don't do it. You don't do the addition. You don't do the division. You just decide which tool to call. You just decide which tool to call. Okay. So this allows LLM means model to decide when to call the tool. When to call the tools. So that means you need to tell that for addition, I have the tool. For division, I have the tool. For something else, I don't have the tool. Like that. So therefore, bind the tools. How do I do the binding? So it's very simple. Triple RS. Right now, how we have? This is the name. This is the name we have given, right? Triple RS tools. Now binding, right? Triple RS, LLM underscore tools. Triple RS LLM underscore tools. For model, what is model? Triple RS model dot triple RS model dot. Then there is a bind tools. Yes, bind tools. Then pass your tools information. Pass your tools information. That's it. Pass your tools information. That's it. Now just to execute the tools, we are good, and binding also we are good. Now you create a message. I'm just using the next cells here. If you want, you can put all the things in the same cell, no problem. So the next one is start the conversation. Means prompt. Start the conversation, prompt. So in the case one, scenario one, we have given the prompt, right? This is nothing but what? User prompt. User prompts in LangChain are called human messages. So therefore, create a human message. Okay, so user underscore prompt equal to human message. Human message that you need to import it, right? Did we import already? I think here we imported. Let's import in our cell also. Okay, human message. Then if multiple things are there, you can put bracket also. Human message that will have what? Content, right? Content equal to, then you can mention whatever prompt you want. So this one, I'll use the same one. Then close this. Like this, you can create the user prompt. Like this, you can create the user prompt. Just execute it and see. We are good. Now let's go to the next cell. Now we have the functions. Functions are there. Then we binded the functions, models, tools, sorry. We have the tools. We binded the tools to the model, and we have the prompt also. First, let's give a try. So let's okay. Now invoke the model. Invoke the model with the tools. How do I do that? Here, this is the one. Okay, so this is the one dot invoke, and you can pass the message, human message, or you can pass like this also. Okay, you can pass the user prompt. You can pass the user prompt. Okay, or directly you can pass it. You can pass the user prompts or directly you can pass it, no problem. So now you got the response, or directly also you can pass it. Either one is fine. Okay, just execute it. Just execute it. Now you are getting the results. So let me capture these results into a variable. Let's say RRRS underscore response equal to this one. And let me print this response and execute it. And execute it. You can see. This is what the response we are getting. Okay, this is what the response we are getting. Now, if you observe this AI messages, right? Now, you please pay attention here. If you see the AI messages, in the AI messages, can you please observe here? What I did is RRRS tools dot invoke. Then I said, how do I know model is done this or tools are done this? Okay, we got the response. We are good. How do I know my tools done the math or my models are done the math? So this is the code we have written. Now the question is, this is the code we have written. Now the question is, how we know models done the math? That means that addition, division and all are tools. I have written the tools, right? Tools done. How do I know? Okay. So for that, what you can do is that, so we got the response, right? In the response, if you see, this is the response. Okay. In the response, there is a tokens, all these things. Yeah, you can see tool calls. There is something called, yeah, tool calls here. So you can see tool calls. In the tool calls, you can see it is clearly suggesting tools. It is clearly suggesting tools. That means model is telling that there is an addition. You call the add to. See, add one is not there. See, I have written add one, add two, add three. Sorry, div, right? Right now requirement is what? Add three numbers. Add three numbers means what? Add two is required. Add one is not required. That's why model is telling you go on to call add two, do the sum. You go on to add call two and do the sum. After sum, you go on to execute this function and do the division. Like that, model is suggesting to call these tools to perform the task. Please pay attention. Okay, if you see in the case scenario 1, I will execute the scenario 1 once again. So this is a scenario 1, right? So here model has done all the math. Model has done all the math. So that's why if you see AI message, nothing is there in that. Just search with the tool calls. Okay, you can see tool calls are empty. So here tool calls are empty. There are no tools. That means all the math done by, so this is the case 1. Case 1, all the math done by the model. All math done by models means LLMs. This is the case 1. Now in case of case 2, we have the tools means our functions. So that's why when I execute it, we are getting the results. That 6.6, if you want, you can see there will be somewhere else. Anyway, we'll see that. Okay. Okay, this is the response, right? Let's take that once. And go to our notepad. Paste it. Case 2. All math done by. Here tools are nothing, empty. In the case 1. All math done by tools. Okay, means functions. To prove that, I just pasted the response AI message. So in this, you can see the tool calls. Okay, tool calls. Okay, tool calls. And so you can see here, this one. It is suggesting clearly. Okay, it is suggesting clearly. Okay, so that means model is telling, hey, this is what your prompt. Okay, this is what your prompt. That means you are trying to add three numbers. You already have a tool. Okay, you already have a relevant tool called add to. Okay, add to. Go and execute it. Let me execute it. Once that is done, for division, you already have a tool. You already have a tool. Let the tool will do the division. Let the tool will do the division. Like that, it is suggesting the tools now. That's why I said, you binded the tools, right? You binded the tools. That tool information you pass it to the model. That tool information, that's why you can see here. So you are invoking with the tools. Invoke method, yeah, you can see. With the tools, you are invoking the model. Now model knows what tools we have, what functions we have. So instead of it is doing the mathematics, it is suggesting, hey, for adding three numbers, you already have a function, let that get executed. For division, you already have a tool, let that get executed. Like that, it is suggesting. Now, in the suggestions, you don't see add one. Why? We want to add three numbers. For adding three numbers, add two is required, not add one. Now you understand. Based on the description only, it is finding the tool. Based on the description only, it is finding the tool. Okay, that is the reason I have given add one, add two. I can give add three numbers like that. Add three numbers like that. Meaningful name I can give. That is what the standard. But yeah, for understanding purpose, the bigger picture, that is what to make highlight of this particular description, I given some random names. So therefore, tool clearly suggesting, hey, okay, sorry, model clearly suggesting you already have tools to perform the three numbers addition. Let that get executed. You already have a tool called RRRS div for division. Let that get executed. Like that, it is clearly suggesting. Like that, it is clearly suggesting. So in this case, model is the one who is deciding which tools. Model is deciding. So you can see decision. So we have three functions, right? There is a add one. Okay, there is a add two. There is a RRRS div. Now the model is suggesting these two only. Model is not suggesting add one. Why? It's deciding. How it is deciding? That's the power of agentic behavior. That's it, that's it, that's it. So therefore, model is the one which is invoking. Model is the one which is suggesting. Okay, model is the one which is deciding which tool to use. Model is the one which is deciding which tools to use. That's it. Okay, let's continue. So you need to understand this clearly. Okay, fine. So we displayed and we are good. And let's say I want to see the tool list. I want to see the tool list. RRRS response is having tool list, right? So if you want to see, you can say RRRS, that is name is what? Tool calls, right? Yeah. Tool calls, tool underscore calls. You can print it, it will print the tool calls. So that means, so you can see clearly. Model is suggesting there is a add to function, div to function, add to call, div to call. It is suggesting. Okay, it is suggesting. Model is the one deciding which tools to execute. Okay, here we need the three numbers addition. For that it is suggesting this. Then division. For that it is suggesting. The other things are not suggested. That's called decision power. That is called decision. So here model decided what tools to call, when to call. Both what tools to call, when to call. That's it. This is how you can see the tool calls also as part of your response. In the scenario 1, tool calls are empty. In the scenario 2, you can clearly see the tool calls. You can clearly see the tool calls. All right. So the next, okay, now we see the tool calls. Now I want to know what exactly happening in the each iteration. So that means how the message is going, how the message is going to model, how the message is internal things I want. Right now, what is happening? If I do this triple RS response, I can see only one, right? Only one is coming. Like this, it is coming. Okay, like this, it is coming. Only one. I want to see all the internal things. Okay, so right now this is what it is. I want to see how the request is going to the. I want to see all messages, not just AI message, not just AI message. I want to see all the messages, not just AI message. Then how to do? I want to see all the messages, not just AI message, all the messages, not just AI message. How to do that? If you want to see all the AI all the things, then what you can do is that you can create one more and write a loop and iterate it. While true, this is the fixed coding here. While true, uh, LLM will choose from these tools when solving, right? So for that AI message equal to you just invoked the with the user prompt, right? Okay, invoke with the user underscore prompt. Huh? That's what we have given user prompt. Where is that? Yes. So I'm just putting in the loop so that you can see. Or what I will do is that I will just copy here. It will take lots of time to type it. You understand the context, right? Let me, at least that loop I can copy it so that we can save at least 10 minutes of time to type all these things. Okay, I am just pasting this. I am just pasting this. Why it is giving error? What is the name we have? This is the name we have. RRRS LLM tools. All right, that's it. Now execute it. Now execute it. There is a tool message. Tool message also we need to import. Okay, so let's import the tool message because it's not there right now. So we imported the human messages, right? There only you can put the tool messages. Yes. Okay, we have different types of messages, right? Human messages, AI messages, tool messages, like that. Okay, now let me execute this. First, see if there are errors. If no errors, then we'll discuss. Yes. Right now, no errors. Let's discuss. Okay, fine. Now you can see here. Can you please observe here? So what are we trying to do here? So we are just saying while true, and we are trying to invoke the model. We are trying to invoke the model. When you try to invoke the model, you are invoking with the user prompt. Okay, that user prompt you appended to AI messages because initially whatever you have, that's a AI message. It's kind of appending. Then you get the tool calls, right? You can see tool calls. that also you append again. We can have multiple tool calls, right? We can have multiple tool calls. So I am checking if tool calls not empty. Not empty, then so basically the execution flow, how the execution flow. If there are no tool calls, let's take the scenario one. If there are no tool calls, that means it's ended. Execution is ended. If there are no tool calls, execution is ended. Okay, if there are no tool calls, execution is ended. So you can see the scenario one, no tool calls, execution ended. If there are tool calls, so scenario two, if there are tool calls, then those needs to be executed, right? Okay, so if tool calls, there can be multiple tool calls, that's a loop. So there can be multiple tool calls, that's a loop. Execute the first one. You can see execute the first one. And this first one is giving the results, right? That results we are keeping, okay, that results, with this results, we are keeping in the tool map and invoking that one. So if you see here, when you do the print, okay, tool results, okay. So like this, it is executing all the tools. Like this, it is executing all the tools. Like this, it is executing all the tools. So tool 1, tool 2, tool 3, all these things. And so what is the tool 1? You can see here. This is the one. Execute. That means the tool 1 is nothing but adding 3 numbers added. Once added 3 numbers, that is kept in the results. Then again it is reiterating. Kept in the results, kept in the results. And finally, that results is nothing but our content. Our results is nothing but our content. That tool message got displayed. You can see the tool message. That means um, so whatever we entered is called human message, user message. Whatever model respond is called AI message. Whatever tools are giving the results, whatever tools are giving the results is called tool message. Like this, it is happening. Finally, you can see the sum of three numbers is this one. You can see the sum of three numbers is this one. Then division is this one, 6.6. Like this, you can get the results. Like this, you can get the results. Right now, so if you see here, right now, AI, not only AI messages. So this is the AI message. After that, there is a tool message. Like that, you can see. But you can still see, we can still drill down on this. We can still drill down on this. That means we can have more information. How we can have more information, we'll understand one by one. But for now, you can see tools are executing. What is the guarantee that tools are executing? Let's do one thing. I will just print here something. Okay, print ChennaRRRS add one. I just put the print so that you see that that is called. Okay, this is add two. This is ChennaRRRS. See whether this message is coming. If this message is coming, that means our functions, our tools are giving the math. I just executed. I just executed. Now run this. It is going there. But yeah, if you want to see why add 2 is giving error. Why add 2 is giving error. Oh, here add 3. Why 3? It's a 2, right? Yes. It's a 2. Okay. Now you can see bind this. That is correct. Now execute this. That is correct. Execute this. That is correct. Now you can see here clearly. Add to div. Add to div like that. Okay. The function calls. Okay. So now coming here, execute it. Now you can see. Can you see this one, please? My message got displayed. ChennaRRRS add to. ChennaRRRS add to means what? This one. Okay. So that is the one which is giving 33 results. So total results you can see. Okay. Then ChennaRRRS div got called. ChennaRRRS div got called. That is the one which is giving this division results, total results. So here we displayed the totals, right? That's the one. Like this, and the final answer. Like this, you have all the different messages. In a simple word, we have three types of messages here. AI message, which model is giving. User message is nothing but our prompt, which is a human message, and there is a tool message. AI message, which model is giving. Human message, which we entered, and tool message. That's tool message is nothing but whatever our tools are giving. So like this, like this, we can invoke it and check is that is giving any tools. If tools, then you can execute it and do this all these things. That's it. That's it. That's it. Now execute this one more time. Now you can see clearly our tools are called. What happened again? Let me run this again. There is a function again. Add two, add one. That's correct. Add two, add one. You can also say run all. Okay, if you are if there is any question, just say run all. That's it. It will run all the cells. Now you can see it's coming correctly. So that's about this. So model is the one which is deciding which tools to call, when to call. That's what I shown you clearly in the AI message. Also, you can see it is suggesting all those things. This messages information will keep continue again. Let's go back and see the notes once, please. Or we'll see. Now let me show you the notes for this. So we completed the two scenarios. One scenario is let all the work done by all the math done by the models. Let all the math done by the tools. Further, this is a scenario. This is what we completed. Now we will stop here and we can continue on top of this tomorrow. If you have any questions, go ahead and ask. Else we'll continue tomorrow. Thank you.